everybody, it's Miss Rose. Welcome back from spring break. It's week 30 and we're still talking about area, but this week it's going to be area of circles. So Pi Day might have passed a few weeks ago, but we're ready to talk about circles now. There's a few key vocabulary words that we have to understand if we're going to talk about circles. So the first couple are radius and diameter. So a radius I'll draw over here. If you have a circle, and then there's the center of a circle. A radius is a segment that goes from the center of a circle to the circle. A diameter, on the other hand, definitely related, still passes through the center, but it's this whole big segment that goes from one point on a circle to another. So that whole thing there is the diameter. So the radius is half as big as the diameter. The diameter goes all the way across and the radius just goes halfway. And then a semicircle is half of a circle. So anytime that you see the prefix semi, or you might see demi or hemi, those are all related. They all have something to do with half. So semicircle is half of a circle. So what we're going to be focusing on this week is the circumference of a circle and the area of a circle. Circumference is like perimeter, and you probably at some point learned a formula for the circumference of a circle. You probably learned that it's, you might have learned 2 pi r, or diameter times pi, or pi times diameter. I think I'm going to write it as diameter times pi. So 2 pi r means the same thing because 2 radii make a diameter. So why is that the formula, though? I don't know if anybody ever told you or if it was just a formula to memorize. So I'm going to show you a quick animation that sums up why the circumference of a circle is pi diameters. So there's the diameter, and then they used 3 different colors to wrap them around the circles. There was a green diameter, a red diameter, and a blue diameter, and then there was a little piece left over, and that's because there's 3 diameters plus a little bit more that fit around a circle. Well, how much more? 0.14159 on forever and ever. So as far as how many diameters it takes to wrap around a circle, it takes pi diameters to wrap around a circle. So pi diameters is the formula for the circumference of a circle. So circumference is pi diameters, or diameter times pi. And then the area of a circle is pi r squared, or radius squared pi. I'm just writing the pi at the end because a lot of these we're going to keep as exact answers and not type the pi in the calculator. So I feel like just seeing the pi at the end instead of the beginning of the formula might make it easier to understand. I have a quick little picture to show you for why that's the formula for the area of a circle. So here's a circle. Half of it is split up into yellow wedges and half of it's into blue wedges. And then those wedges are rearranged into like a rectangular shape. And we've got the blue wedges that would make up half of the circumference. So instead of pi times the diameter, half of the diameter is the radius. So pi times the radius. And then that height of that rectangular kind of shape is the radius. And if you found the area, you'd have your pi, and then radius times radius is radius squared. So this is just to sum up why that's the formula. All right, let's put this into practice. Mr. Millington and I have a strategy that we love. We sing a little song to the tune of the Village People YMCA. We say when there's a circle, it's RDCA. So every time we have a problem with a circle in it, that's immediately what we do. We write down RDCA. So if everybody could take a second and write that down, we're going to do that for 4 different examples. So the first example, I give you the radius. Radius is 6. So what's the diameter? Well, we just said the diameter goes all the way across. So if the radius is 6, the diameter is 6 plus 6. 12. That's always how the diameter and the radius are related. What's the circumference? Well, we just learned that it's pi diameters, diameter times pi. So instead of typing it in the calculator, I'm just going to write down 12 pi. Once you know what the diameter is, then it's very quick to find the circumference. You could type that in a calculator and get a decimal approximation. It's probably, I don't know, 38-ish, something like that. And then the area, we go 6 squared pi. 6 squared, 36. 36 pi. So the radius is 6 centimeters, the diameter is 12 centimeters, the circumference is 12 pi centimeters, and then the area is 36 pi centimeters squared, because square centimeters is what we use for the area. The circumference you saw is just a length around the circle. So let's try that again for this second example. There's a circle, so RDCA. This time I gave you the D is 14 inches. So what's the radius? Half of that, 7 inches. Circumference is quick if you know the diameter. Diameter is 14, so it's just going to be 14 pi inches. And then what's the area? Well, we have to do 7 squared pi. So 49 pi square inches. Let's try a couple more. Hopefully you're starting to get into the swing of things and you see how it works. So what should you write down? RDCA. Why don't you pause the video and try it for yourself, and then you can come back and check. So if you're checking your answer, the circumference was 22 pi. So all you have to do to find the diameter is divided by pi, take the pi off, 22. The radius is half of that, that's 11. And then you need to know the radius in order to find the area. You square it. 11 squared pi is 121 pi. The units on it are radius is 11 centimeters, diameter 11 centimeters, circumference, 22 centimeters, circumference 22 pi centimeters, and area 121 pi centimeters squared. All right, our final one. Like I said before, write out your RDCA, try to pause it and see if you can do it for yourself. All right, if you're checking, the area was 81 pi. I just realized I made a typo. It shouldn't be centimeters. It should be centimeters squared. This one might be a little trickier to find the radius. It's, radius squared pi. So you want to square root the 81. So it has a radius of 9. Diameter is twice as long, so that's 18. And then the circumference then is just 18 pi. So 9 centimeters, 18 centimeters, 18 pi centimeters, but then the area should have been centimeters squared. All right, next up, we're going to look at a semicircle. Remember I said semicircle is just half of a circle. So what do you do to start this one? RDCA. The 10 that was given, that's the diameter. So let's fill out the rest. Half of the diameter is the radius. The diameter, I just have to put pi on it, and that's the circumference. And then the area, I have to go radius squared pi, 5 squared, 25 pi. All right, am I done? No, it says find the area and perimeter of the semicircle, not the circle. So for the area of the semicircle, let me switch colors. Area of the semicircle. Semicircle, remember, is just half of a circle. So I really could just take half of 25 pi. 12.5 pi centimeters squared. So how do I do the perimeter then? Do I just take half of the circumference? Close. You take half of the circumference, but that's not the perimeter of the whole shape. We have to make sure that we also add on the rest, that line segment that's part of the shape too. So be very careful with that. So for the perimeter, I have to make sure to take half the circumference, so half of 10 pi, but then I also have to make sure that I add on the 10. So that ends up being 5 pi plus 10. You cannot combine those because one has a pi on it and one doesn't. So the only way you could combine it is if you did 5 pi in the calculator and got the decimal answer. So that would be the perimeter of the shape. So don't forget the extra little segments when you're finding perimeters. It's an easy thing to accidentally forget. All right, the last thing that we're going to be studying is what if our diagrams are more involved? What if there's more than just a circle? So I want to revisit this, find the area of the shaded region. So we talked before about a lot of times shaded region problems are like, picture this used to be a shaded in square, and then somebody took a circle and just cut it out. So we'd subtract the circle. So that's how I want you to think about this. We're going to do area of the square minus the area of the circle. Somebody just cut that right out, and all that we were left with was that leftover part of the square. So it says the polygon, a square is a type of polygon, has a side length of 8. So you might wonder what that has to do with the circle. You know, you could say, oh, 8. Well, I can quickly find the area of the square, right? 8 times 8. But how does that help you to find the area of the circle? Well, look closely. If I draw in the diameter, what do you notice? The diameter is 8. So let me do RDCA because there's a circle in the problem. Diameter is 8. I can cut that in half, and that's the radius. I can put a pi on it, and that's the circumference. And then radius squared, 4 squared pi. So all you have to do then to find the area of the shaded region is just go area of the square, 64, minus area of the circle, 16 pi. And then they didn't give us units, so we can just say square units. If you're not sure if you subtracted in the right order, you could type that in a calculator, and if you get a negative answer, then you know that you subtracted it backwards by accident. All right, let's do one more really similar, but a little more complicated because instead of a square, there's a hexagon. So it says the hexagon is also a polygon with a side length of 8. So polygon side length 8. So what does that have to do with the circle at all? Well, remember it gets split up into equilateral triangles. So 8, 8, 8. It actually means that the radius of the circle is 8 also. So let's do a quick RDCA. Radius is 8, the diameter would be 16, so the circumference would be 16 pi, and then the area would be 8 squared pi. 8 times 8 is 64 pi. So to do the shaded region, I like to look for which one's bigger. This time it's the circle. And then somebody cut out the hexagon and took that away. So we have our circle area already. It is 64 pi. Then we have to remember how to do this hexagon area that we learned how to do a couple weeks ago. So remember that we take the 8 and we split it into 4 and 4, and then the height is 4 root 3. So for the area of a hexagon, we have to do the triangle first. We go base times height divided by 2. 8 times 4 root 3 divided by 2. Don't put the root 3 in the calculator. I like to go 8 divided by 2 is 4. 4 times 4 is 16. And then the hexagon is just 6 of those. So again, don't type the root 3 in the calculator. 6 times 16 is 96. Root 3. So that's the area of the hexagon. So for the shaded region, I look up at the rule that I made for myself earlier. I said I was going to do the circle area, that's 64 pi, and then I was going to subtract the hexagon area, 96 root 3. And then a lot of times people panic, like, wait, 64 minus 96, that's going to give me a negative number. 64 pi, so it's a lot bigger than 64. But type it in a calculator and make sure that it doesn't give you a negative answer, because if it does, then you know that you did something backwards. All right, give the homework assignment a try. We have lots of areas of circles and circumferences of circles for you to practice. See you in a minute.